Alright guys, so here we are doing another one for equation 3. This one's solving for time. Now if you remember, equation 3 is the full equation looks like this. Is equal to original velocity, or the starting velocity, times time plus 1/2 at squared. And we're going to solve for time now, which is kind of tricky because there's two of them. Now the algebra is kind of advanced if there is an original velocity, so I'm probably not going to do that in this class. I'm not going to do that in this class because it's a bit tricky. I might do it once and maybe for extra credit or something like that, but right now I'm going to definitely do it where this is all zero, because it's the initial velocity is 0. So I'm going to do it so you're pretty much just going to have this equation right here, which is, you know, enough. So an apple falls from a tree from rest, which means I get to do this right here, accelerating at a rate. So I have an acceleration rate of 9.8 meters per second squared. By the way, we're going to be doing gravity problems later on, so you can just type it in exactly as you see it here as of right now, in case you've taken this class before and you're like, wait a minute, I thought it was negative. We're just assuming everything's positive right now, so and that's totally fine. It's the same numbers either way. How long does it take for it to fall 10 meters? So I have a 10 meter. What is that? It doesn't say distance. It doesn't say distance, but we know what a meter is. A meter is a distance, so you know, let's do this. Delta x is a distance, right, or a displacement. And so we're going to put 10 meters. What else do I know? How long does it take? So they're looking, they want me to know the time, and that's it. Is there an equation that has all three of those? Let's check it out. Let's see. This one has a final velocity. I know the starting velocity, it's 0. I know the acceleration. I'm looking for t. This looks like the right equation, except I don't know how fast it's moving at the end, so I'm not going to use it. This one, I don't know how fast, the v. I don't know how fast it's moving at the end. Plus, there's no acceleration either, so this is not going to work. Although I should say that it could work technically if I did have the final velocity, because there is a distance and there's a time. But there's no final velocity. In this problem that we're working on, it doesn't have a final velocity, so we're not doing that one. And if you look at this one, same thing right here. There is no final velocity, so I don't know what it is. I don't know how fast it's going when right when it's about to hit the ground. I don't know how fast it's going then, and it's not asking me to find it either, so I don't need it. That brings us to this one. I do know this. It's 0. I know how long it's going to take. Oh no, they're asking me how long it's going to take. Okay, so the t's. I do know the acceleration, and I know how far I went. So this is the one we're going to use, and that's why we're doing 3 right now. So let's plug it all in and find out here. Let's see, delta x is, what is the change in position? 10 meters, and then it's equal to 1/2 a. What is a? It's 9.8. and times t squared, of course, right? And let's take 1/2 times 9.8, and that's 4.9 times t squared. That's equal to 10. And then don't forget to pause this if you're trying to write this down or take notes or trying to understand it. Don't forget to pause it. I don't know what that dot. Oh, that's 4.9. Yes, 4.9, because 1/2 times 9.8 is 4.9 times t squared as well. 10 on that side. Now let's divide. Let's try to get that t by itself. So let's get rid of that 4.9. and divide by 4.9, which is going to be about 2. It's going to be 2.1-ish maybe. Let's get the exact number from the calculator. Now, how do I always end up closing this calculator? Does it close by itself? Alright. 10 divided by 4.9 is equal to 2.04. So let's go 2.04 is equal to t squared, and we're just about done. So the amount of time it takes, if you square it, it's 2.04, but I don't want to know if you square the time how long it takes. I just want to know how long it takes. So let's get rid of that squared right there by square rooting this, and we'll square root this side. And when you square root the t squared, you get t, and when you square root 2.04, you get, where's the square root button? There it is right there. Square root 1.43. I just rounded up 1.43. That's fine. And don't worry about rounding on the Moodle quizzes. If you're within 5% or 10%, Definitely 5%. If you're 5% or less, and sometimes even 10% or less closer from the real answer, you're going to get the answer correct. So it's not like an exact thing. It gives you some play. So that's the right answer. So T, I'll write it down nicer, 1.43 seconds. So if you have something 10 meters high, that's like maybe like 5 times my own height, and you drop it, it should take about 1.43 seconds to hit the ground, according to our calculations here. Alright? So, thank you, and try some practice problems out doing that.